funny enough. There you go, Yakov. Look at that. You can actually follow her on YouTube. So, nice. And if she gets enough, they'll start putting ads on there. And Rebecca, you're going to have like thousands of dollars pouring in pretty soon. Wow.
Gonna retake the class for the rest of her life and make money out of it.
Here comes the kill. Probably saying no. All right. So tonight is the last night of chapter 7. We're just going to do surface area tonight. We're going to do surface area tonight. Just going to do a couple of examples. Not going to go into it in a really big way. I'll take homework questions later. I want to get the new stuff out of the way. So tonight will be the end of chapter 7. So we'll be done with spinning things around. I'm sure we're all ready for something new to come up here. So I'm going to go through, I think, 2 or 3 examples tonight. It'll be a little short. And then I'll, if anybody's got homework questions, we'll do it from there. Okay, so here we go. Tonight we're doing surface area. Now, surface area involves using the arc length formula that we did last time with one little addition on it. So surface area. Just going to do a real quick thing of where the formula comes from. It's essentially the arc length formula with another piece thrown into it. So just a real quick thing. And like everything else we've been doing, so when we did at the end of Calc 1 and we started here, we use rectangles a lot to do area between curves. We spin those rectangles around and they make disc washers and shells. With arc length, we used a repeated geometric object of a straight line. Straight line. We used Pythagoras' formula. We came up with arc length. So we're going to stick with that. So if we have a function, okay, so there's our function from A to B. And we're going to spin it. This is the last night we're spinning things around. If we rotate that around, that function, we could use disk method to find the volume of that object. But tonight we're not doing the volume, we're doing the surface area that creates. So that looks like a vase or something like that. So we're not using rectangles tonight, we're using a point, a single point. So if I put this point right here, and I rotate just the point itself around this axis, what shape does it make? That point goes spinning around. What's the shape the point makes?
It'd be a ring.
It'd be a ring or a circle, right? So this point goes swinging around. It will create a circle or a ring. So if we measure that around, the thing that we'll use to measure a circle is the circumference. What's the formula for the circumference of a circle? The formula for the circumference of a circle. The circumference, what's that formula?
2 pi r? Or?
Yep, 2 pi r. Yep, that's the circumference here. Oh, wait a minute, got somebody coming in here. Yeah. Now, I'm going to change the word circumference for our purposes tonight. So the circumference is the length of that circle, right? It's the length around. How much rope does it take to make that? Tonight, we're going to think of not circumference. We're going to think of circumference as the surface area of that circle. Same concept, same thing, I'm just changing the words, right? And the radius, what's the radius of that circle? The x-axis is spinning, So the radius would go from here up to here, and that would be the radius. But what is the radius of that circle? What's the length of that line? How long is that line? From the x-axis up to the curve itself, that would be the
function.
function. Excellent. That was you, Jordan?
Yeah.
Excellent. Perfect answer. That radius is the function. Excellent. So no matter where I pick an x, so every point on here, all of those lines are the radius, radii, plural of radius. So each of these blue dots, right, they all form circles when it swings around, and that gives us the surface area. So take away radius and get the function itself. So that would be the surface area of one circle. That's the surface area of just one circle. But we're going to do the whole length of this continuous function. How many points do we have from A to B? How many points are there?
Infinite?
Infinite, exactly. Infinite comes into all of this. So we're going to swing around all the infinite quantity of blue dots. They're all going to make circles. We're going to do the radius, the circumference surface area of all of them, and then add them all up together. So the number of blue dots we have, since they're all on this curve, the quantity of blue dots that we have are points. The number of them is the arc length of that curve. So we're going to do the radius times the arc length, and that's where our formula comes from. So the formula for surface area is this. So surface area formula is, we're going to go from A to B. 2 pi is a constant, so that comes out front. Then we have the function. So that's the radius of all the circles. And then we multiply that by how many circles we have, which is the arc length of that function. And that's our formula for surface area. That's the arc length formula we did last time. And then we're going to multiply it by all the circumferences, whatever, we're going to multiply it together. Now, it turns out, so the arc length problems, the algebra can get pretty awful. And problem number 9 on the homework, had some bad, I hand wrote a solution to problem number 9, and I put it up in files so you can look at it there. All right, so there's our formula. So we're going to do a couple examples tonight, and then we're done with chapter 7. So here we go. First example. Y is equal to the square root of x. And we're going to go from 0 to 1. And so we're going to spin that around. So square root of x. The square root of x is the top half of a parabola. We're going over here to 1. We're going to spin not the shape. So if we spin this around the x-axis, it's going to make a bowl. So the word for that is a paraboloid, but it's a bowl sitting on its side. Now, using the disk method, we can figure out how much water that bowl will hold. That would just be simple disk method, pretty simple problem. But tonight we're going to do the surface area. So if you had this bowl and you wanted to cover it with gold, how much gold would you need? Or cover it with paint or something like that. So it's surface area. All right. So here we go. I'm going to use the other board. So we have our function is y equals the square root of x. We need to do that derivative. The derivative of the square root of x is 1 over 2 times the square root of x. And I'll pause right there in case anybody has a question about that. Questions about if that's the derivative. So to do the steps in between, you would change this to x to the 1/2 power and then do the derivative, right? And you'll end up with this. Now, we need to square that. If we square the derivative, we get 1 over 4x. All right, questions yet? Don't be shy if you're not sure where something came from. Okay. Now, in the formula for arc length, we have to do 1 plus this. So we have to do 1 plus this. This expression here is what's under the square root for arc length. So now I'm going to combine both of these fractions. So we need a common denominator. So we get 4x over 4x plus 1 over 4x. I'm just adding these up and making a fraction. We now have the denominator here. So that leaves us with 4x plus 1 over 4x. Whoops, the keel's coming back in here. Hang on. Somebody lost their connection. I'm just letting them back in. Okay. All right, so function, derivative, derivative squared. Now we do a little bit of arithmetic to make that the expression under the square root formula for arc length, and a little bit of arithmetic takes us here. All right, going back to the other whiteboard now. So we're rotating this piece of the function around, and we're doing the surface area of this. So putting everything into this formula, our function, so we're going from, in this problem, we're going from 0 to 1, because that's what the problem gave us. Our function is the square root of x. And we just did the formula that goes under the arc length here. So we get 4x plus 1 over 4x dx. Everything's going to be around the x-axis in this homework here. So I'm going to stop there in case anybody's got a question. Questions, anything yet? Okay, now I'm going to do a little bit of algebra. I'm going to use this concept. Don't write this down. So if you have the square root of a over b, I can break that into, whoops, square root of a over square root of b. So I'm using this little property here. I'm going to break this piece into 2 square roots. So our surface area becomes 2 pi, the integral from 0 to 1, square root of x times the square root of 4x plus 1 over the square root of 4x dx. So from here to here, I just split this into 2 square roots. Just waiting in case somebody's got a question. All right, I'm running out of room, so I'm going to come back up here. So this becomes pi 1 square root of x, square root of 4x plus 1. And the square root of 4x is 2 times the square root of x. This became that. All I did from here to here was do this square root. Now, if you look carefully up here,
That fraction include the square root, the first square root of x.
say that again.
The fraction, does that include this first square root of x? Does that go over the two root x?
Oh, we're multiplying, right? It's this times this. So the whole thing is just underneath. Because we're multiplying here, I can write it as one big fraction. Right? If I have 2 times 3 over 7, I can write that as 2 over 7 times 3. It's all the same thing. So remember, a whole number is a fraction, so it all just works out. Michaela, do you have a question?
No.
Oh, okay. All right. So good so far in the algebra here? All right, now, what cancels out? Some stuff cancels out up there. What's canceling out?
Radical x.
Yep, the square root of x's cancel out. What else cancels out?
The 2's.
The 2's also cancel out. This 2 on the bottom cancels out with this 2 on the top. This 2 is just a constant, so it can come out. That leaves us with this. Which doesn't look so bad. And now the question becomes, how do we do that integral?
U substitution.
Yep, U substitution is right. We've got an x to the first on here, so we're going to do U substitution. U is equal to 4x plus 1. That's this. We do the derivative of both sides with respect to x. So we get du is equal to 4 dx. This 4 is accounted for right here. This 4 doesn't appear anywhere up here, so I have to pull this over. So we get 1/4 du is equal to dx. And that will replace this. So U substitution, now we rewrite it. So we have pi integral. This 1/4 is a constant, so it can come out front, and that leaves us with the square root of u du. Because all of this is u, so it goes right under there. Which looks pretty straightforward. But there's one other thing I have to do yet. What's missing up here? What's missing on that integral?
The interval.
Yep, the bounds, exactly. The bounds are missing on there. Mariana, yes, good one. So these, since this integral is in terms of x, these are x values. This integral is in terms of u's, so I have to change them, and we use this. When x is equal to 0, u is equal to 1. When x is equal to 1, u is equal to 5. And that's the integral that we're going to do. All right, I'm going to pause for a minute in case anybody's got some questions. All right, so now we do this integral. So get rid of the square root sign and just write that as an exponent. So we get u to the 1/2 power. So our surface area is this, and this now becomes, here's the pi over 4, that's a constant. We add 1 to this exponent. 1/2 plus 1 is 3/2. We divide by that exponent, which means we multiply by 2/3. And this takes us to pi over 6 u to the 3/2 from 1 to 5. And I'll pause there again in case anybody's got a question. So the last step is to throw these numbers in here. So our surface area of that bowl that we created by spinning that curve around will be pi over 6. Top number in first, we get 5 to the 3/2 minus 1 to the 3/2, which is just 1. And that's our exact answer. Because the square root of 5 is not a nice number. It's irrational. It's 2 point something, but the decimals never end. Now, if you wanted to estimate it, 5 is pretty close to 4. The square root of 4 is 2, right? Square root of 4 is 2. 2 cubed is 8. 8 minus 1 is 7. So you're going to get approximately 7 pi over 6. That's an approximation. This is exact. This means approximation. And that's how surface area works. U substitution comes up a lot in the surface area formulas. One question on that one? It's going to do 2 more examples tonight.
You want to test that would be a valid answer? Approximation?
Well, this is an engineering course. I don't really care what the answer is. Both of these would be good, right? So this is exact. That's about. How did I get pi over 6? So are you okay with the pi over 4, Nicholas? You see where that came from? Okay. When we did the integral here, we got an exponent of 3/2, and then we have to divide by that new exponent. So dividing by 3/2 is multiplying by 2/3. This 2 on top canceled out one of the 2's down here and left me with a 2. And then 2 times 3 gave me that 6. It's okay with that? Yep, there it is. Fractions, right? They always, the F word of math, they always trip us up. All right. Do another example now. So these are pretty straightforward. Your homework tonight, there's like 4 something problems. It's not a lot. So the whole point of chapter 7, to me, is if you're not going into physical engineering like bridges and tunnels and making parts for machines, this is the application app. The whole idea here is we've taken a simple geometric object, a rectangle, a disc, a washer, a line, and we've repeated them infinitely numbers of times, and we're able to answer questions like, what's the volume of this oddly shaped object? What's the surface area of this weirdly shaped object that you couldn't do any other way? So that's the takeaway from this. Okay, next example. Y equals x cubed. And we're going to go from x equals this to 2. Okay. So y equals x cubed looks like this. So, oh, that's bad. Let me do that again. Not that it matters. So cubics have that characteristic S shape to them. We're going from 0 to 2, so we're only using this part right here. So if we go over here to 2, that puts us up at 8. So there's the shape. We're going to spin that around the x-axis. Everything will be around the x-axis. Nothing changes if it's y, but we spin that around. And that's going to make a shape that looks like this. All right. It's going to kind of, when that shape goes spinning around, it's going to look like a funnel, but there's no hole on the end. So we're going to figure out how much paint on there. Now, if we wanted to do the volume of this shape, this would just be a simple disk method on here, just plain old disk method. Right? So I'm going to take away this drawing because I need some room here. So we need the derivative. The derivative of x cubed is 3x squared. We need to square that derivative, and that will give me 9x to the 4th. So here's our surface area now. 2 pi, 0 to 2, because I said so. The function goes here, and then it's the square root of 1 plus 9x to the 4th dx. So the 2 pi x cubed is the circumference of one of those circles that gets spun around, and then we multiply by the arc length, which gives us the circumference of all the circles added up together. Okay, questions yet? Hang on, I think if you got a question, I keep like sore throat. I'll be right back. All right, I'm back. All right, good so far? Okay, so how do we do that integral?
U substitution.
I'm sorry, I couldn't hear that. What?
U substitution.
Yeah, U substitution. Who said that? Usually a name pops up. Who said that?
Michaela.
Oh, Michaela. Okay. Yeah. Now your name pops up. I don't know what you see on your screens, but when somebody talks or something, their name box gets big or the picture.
Yeah.
Oh, you see that as well?
Yeah, like it goes like has like a yellow border around it usually.
Oh, that's why everybody's shy with pictures, because suddenly you're full size, right? I have to tell you, it's very strange. All I see is a little rectangle of me up in the corner. I don't appear full size on here. but it throws me off when I'm like watching myself do this kind of stuff. It makes me very self-conscious. Okay, so Michaela is correct. It's a U substitution. And here's the trigger for a U substitution. You've got a complicated expression here with an exponent of 4. You have a simple expression out here with an exponent of 3. So when you have an integral where x shows up in 2 places and the difference in their exponents is exactly 1, that's a pretty good clue to probably try U substitution. So a bunch of the problems tonight, well, and there's not many, I think 4 or 5, U substitution will come up, but not all of them. So we're going to do U substitution here. This will be our U. So U is equal to 1 plus 9x to the 4th. We do the derivative of both sides with respect to x. So we get du is equal to 36x dx. There is no 36 in this problem. So we have to have an exact match up here. So the 36 has to come over to the other side. So we get 1 over 36 du is equal to x. Oh, sorry, I made a mistake. That should be 36x cubed. Sorry, made a mistake. Typo. X cubed dx. And that will replace all of that. Questions? All right. Okay, so now I'm going to rewrite all of this. Oh, yeah, I'm going to rewrite all of this. Hang on. So our surface area is 2 pi. Now, we have to change the limits. We have to go from x values to u values. So when x is 0, u is 1. When x is 2, we get 2 to the 4th, which is 16. We get 16 times 9. What's 16 times 9? I should have picked a smaller number. What's 16 times 9?
144.
Plus 1. Oh, thank you, Michaela. And thank you, Mariana, for doing that quickly. So 145, because we got that plus 1. And these numbers are kind of really irrelevant to what we're doing. They just give us a numerical answer, so we have to pay much attention to them. And then the rest of the integral will look like this. That 1 over 36 is a constant. So that can come out. So there's that. Square root. Get u. And we're down to pretty much what we had in the last problem. All right, good so far. A lot better than arc length. Okay, so we get rid of the square root sign, make it an exponent of 1/2, 2 over 36. So we get pi over 18. And then we get, again, u to the 3/2 power, divide by the new exponent. That simplifies. So square roots come up a lot, by the way. Science, engineering, even psychology. Square roots come up a lot. That's why so many problems have them in there. And let's see, so this 2 comes down here. That turns that into a 9. It cancels out. So here's what we have when we're all done. So we get pi over 27, and we're going from 0 to 2. So we put these numbers in here. When we put 2 in here, we get 2 to the 3 halves. Oh, sorry, not 0 to 2. Sorry. I forget we did that. It's 1 to 145. I was using the old bounds. I forgot I did these. So we get 145 to the 3 halves power minus 1 to the 3 halves power. That's the exact answer. And if you wanted to estimate that a little bit, which you don't have to, I don't care about that, you engineers and that kind of thing, 145 is pretty close to 144. The square root of 144 is 12. So this would be 12 to the 3rd power minus 1 all over this number here. But that's good enough for me right there. And that's surface area. Not so bad, right? So I'm just going to do one more simple example, and that's it for surface area. Okay, one more simple little example. Y equals X. Doesn't get a whole lot more simple than that. So Y equals X looks like this. It's a 45-degree line. And we'll go from 0 to, I don't know, we'll go from 0 to 4, right? So we're going to spin that around the x-axis. What do we get when we spin that line around the x-axis? What shape do we get? It's a straightforward one to visualize. So what shape do we get? Yeah, we get a sideways ice cream cone. It's going to look like this. Right? Using the disk method, we can figure out how much ice cream you can get in there, but we're interested in the surface area. So how much chocolate would it take to cover that cone in chocolate? Some of you going into engineering, there are problems that you will get where if you wanted to cover the surface of that cone with chocolate and the chocolate had a given thickness, what would be the volume of chocolate? So you got some of that coming up. That's an important thing to do, right? Okay, so here we go. I have all these colored markers here and I get confused about what's going where. Okay, so first you do derivative. Derivative of x is 1. Y prime squared is also equal to 1. So our formula is this. Surface area of that ice cream cone is 2 pi. We're going to 0 to 4 because I said so. The function is x. And the square root is 1 plus the derivative squared, which just happens to be 1. And there's our integral. All right.
You put this one on the exam.
What?
You put this one on the exam.
How about if I throw the thickness of the chocolate in there and ask you for the volume of chocolate?
All right.
That would be like an extra credit or something like that, right? You know, there's a danger when you write a test. it's possible to put a question on a test that's so easy, everybody gets it wrong. Because you look at it and you think, there's no way it can be that easy, and everybody overthinks it and gets it wrong. So it's possible to put questions on a test that are too easy. So I'm going to say this to Brandon and Nicole, who are in the class. They're taking discrete math with me this semester, which is right before this class. And it's all kinds of logic and stuff like that. If at the end of the semester, if I ask them what's 1 + 1, they will say, I don't know. You have to give me more information. That I don't know what 1 + 1 is. You got to tell me more. Because it's a sort of it's an interesting class, right? Interesting class. Okay, so now we do this integral. All right, so 1 + 1 is 2. 1 + 1 is 2. So this integral becomes 2 pi, the integral of 0 to 4, x times the square root of 2 dx. So there's our integral. Square root of 2 is a constant, so I can pull that out front. And now we have the integral of just plain old x. So the integral of x is 1/2 x squared, and we're going from 0 to 4. But first, this 2 and this 2 cancel out. So what we get is pi times the square root of 2. We put 4 in here. 4 squared is 16. We put 0 in here, and we get 0 squared, which is 0. And our final answer is 16 pi times, 16 pi times the square root of 2. So pi, so here's an approximation. Pi is about 3. So 3 times 16 is 48. The square root of 2 is a bit bigger than 1. So your answer is going to be somewhere around 50 or 51. But what are our units? Suppose this was measured in centimeters. If my x value is from 0 centimeters to 4 centimeters, what are the units of my answer? What are the units of that answer that we're measuring in?
Meters cubed.
Nope. Centimeters cubed is 3-dimensional volume.
Squared.
This is squared. So this would be units squared. So if these were centimeters, this would be centimeters squared. Gotcha, John P. I see that. So arc length is linear, so it's just centimeters. Area, 2-dimensional area, is centimeters squared. The volume of that ice cream would be centimeters cubed. And you can go to 4 dimensions, 5 dimensions, 6 dimensions, 7 dimensions. You can keep on going up in weird dimensions. So if you had an object that was in 5 dimensions, it would be centimeters to the 5th. And yes, you can have multi-dimensional objects, but that's for a different course. That's it. That's surface area. Pretty straightforward. So anybody got questions on surface area at all? The homework, I think there's 3 or 4 calculation problems. There's an arc length program. There's an arc length problem in the homework I'm sending out to you tonight. And then there's a question that's a thinking question. You have 2 different functions. If you spin them around, which one has more surface area or more volume or something like that? Just thinking. That'll be it. So anybody's got questions? So that's it. We're done with chapter 7 for new stuff. On Thursday, so I'm send out the homework. Also before Thursday, I'm going to send out another worksheet with some concept problems on it. On Thursday, we're going to take a look at everything in chapter 7. So chapter 7 started out with area, just area under a curve, between curves. Then we started spinning those rectangles around. We got disk, washer, shell, arc length, and surface area. So Thursday, we'll start taking a look at all that stuff. The test will be sometime next week. I'll let you know more details on Thursday and how all that's going to happen. So anybody got any questions about anything? Anything? Doesn't have to be this. Can be anything at all.
I have a homework question.
From arc length?
Yes.
Okay. Homework question number 9, by the way, I put the answer handwritten up in files because the algebra is a lot. So were you going to ask me about number 9?
No, 7.
7, okay, good. Because if it was number 9, I would say, read my problem first and let me know if you have any troubles. Number 9 takes a little bit. There's some yucky algebra in there. So we're going to do number 7. This is arc length. John, I don't know where I put my book. Can you just tell me what it is?
Oh, sure. Y is equal to 3/2 x to the 2/3.
3/2 x to the 2/3. Okay. And we're going from where to where?
1 to 8.
Okay. So, and these numbers are they're just arithmetic at the end. You know why this guy picked an 8? Because the cube root of 8 is a nice number, so he was being kind here. So this is just arc length. So we're going to do everything we just did with surface area, but the formula won't have a 2 pi in front or the function. So first we do the derivative. So 2/3 comes down in front. 2/3 times 3/2 is 1. And now we get x, you subtract 1. So 2/3 minus 1 is negative 1/3. And now we have to square that, and here's a place for a mistake. What do we get when we square this? We get x to the what? And here's a place for a mistake, not a calculus mistake, sort of an arithmetic thing. What happens when we square that?
We multiply the exponent by 2.
And we end up with what?
X to the negative 2/3.
Ah, negative. Good for you, John. A very common mistake is to drop the negative because you're thinking, I'm squaring something so the negative goes away, right? So that's a common mistake, but you're just multiplying, so it's x to the negative 2/3. Good. Okay. Now we go to the arc length formula. So the arc length formula, we will have from 0 to 8, and we will have 1 plus x to the negative 2/3 dx. I'm assuming you got that far.
And also it's 1 to the 8.
Oh, 1 to 8, sorry.
That's okay.
Okay, there we go. All right, so we okay here?
That's where I got, and then I just didn't know how to solve it from that point.
And then comes algebra. So the trick to this problem is I have to do this addition. So I'm going to rewrite this. And I'm going to do it I'm just going to rewrite it as a separate thing. In fact, let me do this. It's that algebra always gets us. All right. So we have 1 plus 1 over x to the 2/3. So I got rid of that negative exponent. Now I have to add these together, and this is the common denominator. So we get x to the 2/3 over x to the 2/3 plus 1 over x to the 2/3, right? So I just changed the number 1 into this form, this structure. And now that they have the common denominator, I can add them together. So we get x to the 2/3 plus 1 all over x to the 2/3. Okay, so far?
That makes sense.
Yep. algebra's been around for a long time. Well, this kind of algebra has been around for a long time. The real algebra has only been around for about 100 years. Okay, that goes under the square root of our integral. But I'm going to use this property again. I'm going to break it up like that. So my integral becomes the square root of x to the 2/3 plus 1 over the square root of x to the 2/3 and all dx. All right?
Yeah, I see what you're doing now.
Okay. Oh, since we're not in a classroom and nobody can really see you anyhow, what am I going to do next?
I think you're gonna use the square root in order to change that denominator to x to the 1/3.
Nice. That's exactly what I'm going to do. The square root of x to the 2/3 is x to the 1/3. Perfect. What am I going to do next?
Well, x to the negative 1/3 is the same as that, so you're going to use x to the 2/3 plus 1 as your u, and then do u substitution.
Perfect. Yeah, absolutely perfect, John. Very nice. Comes out to be a u substitution. It's very hard. It's very hard to make arc length problems that are doable by normal people because the algebra gets so awful. So it's tough to come up with problems. So we'll do a u substitution. U is equal to x to the 2/3 plus 1. Derivative of both sides. This gives me 2/3 x to the negative 1/3 dx. So this is, that's my u. This is right here. That 2/3 is extraneous on that side of the equation. So we're going to pull that to the other side and make it a 3/2. We're going to divide it away. So we're going to get 3/2 du is equal to x to the 1/3 dx. And that's how we're going to write this whole problem. And let me see here. I kind of ran out of space. Sorry. So we get 3/2, the integral, the square root of u du. It all turned into that. Pretty slick, right? We got to do one other thing. I have to change these x values into u values to put them here. So when x is 1, 1 to the 2/3 is 1 plus 1 is 2. And here's where the reason for this number 8. If x is 8, we get 8 to the 2/3. The cube root of 8 is 2. 2 squared is 4. 4 plus 1 is 5. And there's the integral. We all good with that?
Can I interrupt for a quick second?
But, yeah.
How did that x to the negative 1/3 dx, how did that become x to the positive 1/3 dx?
Oh, it did. I just forgot to write it. Everything else is good. I just forgot to write that down.
Now would still cancel out the
Well, because our
right. That was a negative. Okay.
it was x to the positive 1/3 down here. So
Yeah.
I just forgot to write it over there, but thank you for catching that. Yeah, that's good.
I'm a little confused. All right.
So John, you're good so far?
Yeah, that makes sense.
And then this is the same as all the other examples I did. So you can take it from there?
Yeah, I got it from there.
Yeah, no, I'm glad you asked that. That was good.
Right,
Yeah.
thank you.
You're welcome. Anybody else?
Just for the fun of it. So what do I do next?
What?
Okay, just for the fun of it, so what would I do next?
Just write that as 1/2 and just integrate.
Oh, okay.
You get u to the 3/2. You get another 2/3. This is exactly like the first two examples I did. All right. Okay. Anybody got anything else? Well, all right. Let's go enjoy this hot, yucky, moist, damp weather, I suppose. So I'll send out some stuff in just a few minutes for the homework for surface area. There's one arc length problem in there, a graph of something called an asteroid, not the cosmic rocks floating around. It's a different shape. Oh, Rebecca, our bounds for the first problem were 0 to 8, but these were all with respect to x. So since we're now with respect to u, we go up here. You plug them in. When x is 0, this all becomes 1. Whoops. Oh, no, sorry. It was 1 to 8. When x is 1, all of this becomes a 2. When x is 8, this all becomes a 5. Ah, gotcha. There we go. All right. It's the humidity. Got us all. Okie doke. I'll send those out. Rebecca will put the recording up on her YouTube channel, and we can all subscribe and like it and click the bell and make her lots and lots of money. All right, everybody. See you back on Thursday. Okay.
Thank you. See ya.
Good night.
Night.
Thank you.